Everyone, good day to you. This is the lesson for April 2nd, 2020 for Algebra 2 Honors. What I decided we're going to do today is kind of start preparing for our assessment of polynomials. Now, before you have a heart attack and you're like, but Mr. Witt, it's been like 3 weeks since we learned some of this stuff. You're right. So what I'm going to do is our assessment will be open notes, open videos, whatever, and you can use your graphing calculators and everything too. The only thing I ask is that you do not talk to anybody else or use, some sort of, communication method to talk to somebody else to, get your answers. I want them to come from you. Okay, I think we'll look at having the assessment maybe Friday, but definitely I'm thinking more like Monday, Tuesday, maybe something like that. And I'll split it up, over 2 sections, or I don't know. I'll assign it over 2 days kind of thing. Anyway, we'll see. Something like that is my thinking. We're just going to practice some factoring because right now, with the way things are, I want to make sure that you have some of the I want to highlight some of the most important skills that you guys need to take away from this unit. And one of those very important skills is being able to solve polynomial equations. Okay, stuff we've already kind of talked about, but I just want to highlight those things right now. Okay, so let's get started here. So the first thing we want to make sure we always do, and this solving polynomial equations is true for quadratics or any other polynomials you might work with. Okay, just remember the quadratics, we have a few other tools to work with, like quadratic formula and stuff like that too. But our main strategy here is going to be make equal to 0, factor, solve using 0 product property. Okay, now of course not everything factors, right? And so if we can't get it to factor, we could also rely on that rational roots test. Using P and Q and stuff like that, and the factors of P and the factors of Q, and then guess and check using synthetic division. Okay, remember that? We might talk about that a little bit more too, but that's not as important as being able to just factor. That's really the majority of stuff that you guys will be working with will be stuff that is factorable, and that's what I'll probably just have us focus on too. Okay, so anyway, okay, let's just do some examples here. So let's start with something like this. And again, all the directions here are going to be solve for the variable. Okay, here we go. So y cubed minus 5y squared equals 0. Okay, so our strategy, right? We want to factor. So let's see here. I can see always check that GCF first. So what's in common is a y squared. And that leaves us with y and a minus 5 equal to 0, right? We'll set each one of these equal to 0. Square root both sides here, so we get y is 0. Again, technically it'd be plus or minus, but you can't have a positive negative 0, so it's just 0. We'll add 5 to both sides there, we get y equals 5. And those are our solutions. Of course, you can always check by plugging these back into the original equation and make sure that they do in fact give you 0, but we know we did our work right, right? All right, let's try another one here. Let's do 4z squared, oh, not z squared, sorry, 4z to the 5th minus 84z to the 3rd. All right, so again, we're going to look and see what we can factor here. So why don't you guys go ahead and try this one. So pause the video, see what you can come up with. Okay, so hopefully the first thing you saw here is we could factor out a z cubed, okay, but actually there's more than that, right? We can factor out a 4z cubed, okay? So taking a 4 out of 4 leaves us with a 1, and then z to the 5th divided by z cubed is z squared minus, and then 84 divided by 4 is 21, and then taking out a z cubed just leaves us with just 21 there, okay? And again, remember this is equal now to 0. Okay, ooh. I never set it equal to 0 in the first place, but that's what we're doing, okay? Yes. So anyway, we'll set then, I should have originally said it was equal to 0, sorry. So we'll set 4z cubed equal to 0. We'll set z squared minus 21 equal to 0. Okay, so we'll divide both sides by 4 here. We'll get z cubed equals 0, and then we'll cube root both sides, and we get z equals 0. Now when you cube root, you do not need to put the plus or minus, but again, that would be moot at this point because, you know, z is just 0 there. Okay, here we'll add 21 to both sides. We'll square root both sides. So you get z equals the square root of 21, which is, well, you can't really square root 21, nor can you simplify it any further, so we'll just leave it plus or minus root 21. Okay, and there are our answers. Now you may remember from a lesson earlier, okay, before this whole quarantine thing, that the degree of our polynomial, which in this case is 5, tells you how many solutions we should have. But if you look here, we only see 1, 2, 3 right there. So where are the other 2 missing polynomials? Well, if you remember, right, this 0, okay, it actually came from a cube root. So the 0 actually counts 3 times. Okay, and so that results in having a solution, or the right number of solutions. We have 5 total then with that. Okay, so just something to keep in mind there. All right, let's try some more. Let's try, let's see here. All right, let's try this one. Okay, so let's see here. It'll be x to the 6th. Oops, let me use my x to the 6th plus 36 equals 4x to the 4th plus 9x squared. Okay, now in this case, right, we can see that we are not equal to 0, so we want to make sure it's equal to 0. So we'll move everything over to one side. So I'm going to subtract 4x to the 4th from both sides, and subtract the 9x squared from both sides. And that'll give us x to the 6th, whoops, minus 4x to the 4th minus 9x squared plus 36 equal to 0 there. Now that equal to 0, we'll see if we can factor. I look for a GCF. There's no GCF. Okay, so we can't do that, but I do see an even number of terms, so I'm going to try and group these. So let's group these first 2 together. Let's group these second 2 together. Let's see if this works. So out of that first group, we can take an x to the 4th, leaving behind x squared minus 4. And from the second group, well, why don't you guys go ahead and try the second group. Okay, hopefully you gave it a try there, and you'll get minus 9 times x squared minus 4. And okay, we have the same leftovers, which means we're on the right track, right? So why don't you guys go ahead and try and finish the rest of it here. Okay, so hopefully you finish the rest of it. We'll have x squared and x to the 6 minus 9 equals 0 like that. Wait a minute, I missed, oh, this is a 4 here I factored out. Whoops, sorry. This is a 4 here. There we go. Whoop. Okay, so this was not next to the 9, it was 4 like that. Okay, perfect. All right, now we can continue trying to factor if we want to here. So for example, x squared minus 4 as a difference of squares, it'd be x minus 2, x plus 2. Okay, you could also just set the x squared minus 4 equal to 0, right, and then factor like that. X minus 2, x plus 2, right? It's quadratic factors to that. So we'll get x equals 2 there and x equals negative 2 as our 2 solutions. Okay, for this one, x to the 4th minus 9, well, that is not quadratic, but it could factor like a quadratic. This is also a difference of squares. Okay, think about it this way. You have x squared squared, right? That's the same thing as x to the 4th, minus 9, which is really 3 squared. Okay, so in other words, this would factor to x squared minus 3 and x squared plus 3. Okay, just like that, right? We have a squared minus b squared here, which factors to a minus b, a plus b. And your a and your b are the x squared and the 3 there. Okay, now we can set each one of these equal to 0. Okay, we get x squared equals 3, which we square root both sides. You get x equals plus or minus root 3. and we subtract 3 on both sides here, we get x squared equals negative 3, square root both sides, you get x equals plus or minus I root 3. Okay, so there are some examples there. Okay. So let's try one more here. Let me see. Okay. How about 32x to the 5th minus 108x squared equals 0? All right, so in this case, again, we're going to look for some, look for a GCF, right? So go ahead and try this one. See how far you can get. So hopefully you saw here we have a GCF, right? We can take an x to the 2nd out, but these both numbers also divide evenly by 4. So we can take actually a 4 out here. I'd use my calculator to help myself there. That's fine. You can do that too. Okay. All right. And so we want to continue factoring here. Well, we have a product, so we can set 4x squared equal to 0. Divide both sides by 4, you get x squared equals 0, and then square root both sides, you get x equals 0. So there's a solution, right? There's actually 2 there, right? Because you got that from square rooting the x squared there, so it's actually 2 zeros there. All right, and since we started with 5, we really need 3 more zeros. So let's see where we can come up with these. Well, if you look at this right here, okay, we can rewrite that as 2x to the 3rd, right? 8x cubed becomes 2x to the 3rd minus the 27 becomes 3 cubed. So what is this? It's a difference of cubes. Now, if you remember, the difference of cubes formula is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And yes, you'll have a formula, sheet available to you, but you need to know how to use this formula when it comes to like an assessment or something like that. Okay, and you definitely need to be familiar with this difference of cubes or the sum of cubes formula. I can also go ahead and write the sum of cubes here too. Oops, a squared minus ab plus b squared. Okay, so in this case, our a is the 2x and our b is the 3, right? So then to follow our little formula here, it will factor to be 2x minus 3 times, and then a squared, okay, is going to be 2x quantity squared plus a times b, so 2x times 3, plus b squared, which is b3 squared. And that's equal to 0. So you get 2x minus 3 here still, and I'll go ahead and simplify this. 4x squared plus 6x plus 9. Okay, now we can go ahead and set this equal to 0. So 2x minus 3 equals 0. So x equals 3 halves. There's another 0 for us, another solution. But then we have this. Okay, this will not factor. But does that mean there's no solutions here? The answer is no. That does not mean there are no solutions. How do we solve a quadratic equation that does not factor? And I'm going to imagine that everyone collectively groaned as they thought about what the answer to that is. That's right, the quadratic formula. So I'll do it right here. X equals negative b, so that's going to be negative 6 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get 36, let's see here, 4 times 9 is 36. Well, 8 times 9, let's just use 72. Yep. Wait a minute. I didn't do that right. 4 times 4 is 16 times 9. Let's see here. So 153. Check myself here before I wreck myself. Nope, 144. Man. It's quarantine brain. Alright, so negative 6 plus or minus square root. Okay, negative 108 over 8. So we're going to have an imaginary number here. I square root and then 108. Okay, good. So 108 is actually, so it's root negative run, and then it's 36 times the square root of, it's 36 times 3. So I can actually make this, oh dear, I did something weird. There we go. So it becomes 6i root 3, right? The 36 becomes 6, that root 3 comes down, that I becomes I right there. And then all over 8. And you can simplify this here, that, and those two will simplify. So we'll get negative 3 over 4 plus or minus 3 over 4i root 3. And there are other two solutions we were looking for there. Okay, so we'll stop there, and I'll get you guys started on your assignment. Tomorrow we will do a little more review, and then maybe Friday we'll start on the assessment. We'll see.